Alright, what we kind of want to look at today, just for fun, is a little proof of the power rule. And the power rule, as we know it, is if you have x to the n power, you can bring n out in front, and then you have x to the n minus 1, the exponent lowers by 1. And, it's just kind of a rule we follow, but there's actually a really good reason for it, and it all just uses the idea of the definition of a derivative. And that's that the derivative equals, again, the limit as delta x approaches 0. It's f of x plus delta x minus f of x all over delta x. Well, let's plug in for the function x to the n power. When I do that, I'm going to have, it'll be x plus delta x to the n power minus x to the n all over delta x. Okay, that's what we're still going to be taking the limit of here. Well, what I can do is using expansion of a binomial, which is what I'm going to do here, raised to some power, and I can use the idea of Pascal's triangle. I can come up with an expanded form of that. So what happens here, it's still a limit, but this is going to turn into, the first term is going to be x to the n power. The next term is going to have n terms. You're going to have x to the n minus 1, and then you have 1 delta x. The next term would be some coefficient, really don't know, but it would be x to the n minus 2, and then this would be delta x squared. And I can keep going all the way down, and I'd have lots of other terms, but then eventually I would have n guys that I have an x to the first power and a delta x to the n minus 1 power, and then I would have at the end a delta x raised to the n power. That was just expanding that guy right there. I still have the rest of this though, the minus x to the n, all that over delta x. Now from here, what you should notice, like we always did, is that the x to the n power at the end should have canceled out. And indeed it does here. You have a minus x to the n plus x to the n. So what I have left, still haven't taken a limit yet, I have n times x to the n minus 1 plus something x, n minus 2, delta x squared, all these terms. Then the nx times delta x to the n minus 1 plus a delta x to the n, still over delta x. And again, what we should notice now, after things canceled out here, we should be able to cancel out a delta x everywhere. And we can. I can get rid of a delta x everywhere. This would become n minus 2. This would become n minus 1. When I do that, should leave me with, still haven't taken my limit, so as delta x approaches 0, n times x to the n minus 1 plus, this would now be something x to the n minus 2 times just a single delta x now, plus, and we're going all the way down, nx, delta x to the n minus 2, delta x to the n minus 1. Well, here's the thing. We now have to plug in delta x being 0. Well, this is a delta x, so that's going to go to 0, which means that whole term goes to 0. Well, every term in here is going to have at least one delta x. The next term would have a delta x squared, so that term will go to 0. Next term will go to 0, all the way up. This term would go to 0. This term will go to 0. So all I'm left with is this guy up front, n times x to the n minus 1, which is exactly what we said it should be. There's just how you can actually prove how to use the power rule.